Hi, Chem scholars, you're welcome back to Organotope Chem Clinic, where chemistry becomes crystal clear. Have you ever wondered why salts conduct electricity in water but not as solids? Or how atoms suddenly become charged and are called ions? In this episode of General Chemistry, we are breaking down the Ionic Theory, and at the end, there will be no confusion, no stress, but just pure clarity. If this is not your first time watching me, please subscribe. And if you are a returning subscriber, type Chem Master in the comments to get access to simplified exam tips. What is Ionic Theory? Ionic theory proposed that when an electrolyte is melted or dissolved in water, some, if not all, the molecules of the substance dissociate into free-moving charged particles called ions. The process of dissociation into ions is known as ionization. The degree of ionization is the percentage of molecules that successfully break apart into free ions. In other words, Ionic theory explains how substances break apart into positively and negatively charged ions when dissolved in water, and how those ions control properties like conductivity and reactions. So if the substance dissolves and conducts electricity, therefore Ionic theory is at work. These ions are only mobile when the electrolytes are in molten or aqueous state. Therefore, these free-moving ions arise only when ionic solid melts or dissolves in water. Moving on, can we attempt the CYK question right here? Check your knowledge. Why is molten sodium chloride used in electrolysis instead of solid sodium chloride? Note that in the solid state, ions are not free to move. Therefore, we subject sodium solid to high thermal energy of about 801 degrees Celsius so as to melt the sodium chloride solid to form molten sodium chloride. In molten sodium chloride, the ions are mobile and can easily migrate to the electrode during electrolysis. And this implies that electrolysis needs mobile ions. Why are ions formed? This is because atoms want a stable electronic configuration, that is, the duplet or octet configuration. So the mobile ions formed when solid sodium chloride is melted can be expressed as we have sodium chloride resulting into this solid sodium ion and the chloride ions. These are the mobile ions in molten sodium chloride. It can be observed right here that sodium loses one electron to form the Na+, while the chlorine gains one electron to become Cl-. Recall from electronic configuration, you can check the video lesson right here. We can express the electronic configuration of the sodium atom as 1s2, 2s2, 2p6, and 3s1. This is the electronic configuration of the parent atom for sodium. But in an instance whereby sodium loses one electron, the number of electrons becomes 10, as against what we have in the case of the parent atom. In the parent atom, we have 11 electrons, while in sodium ion right here, we have 10 electrons. So we write electronic configuration based on the number of electrons in the atom that we are dealing with. So this is sodium ion. We have the electronic configuration 1s2, 2s2, 2p6. It is observed right here that the sodium ion assumes the electronic configuration of which element? That's right, it assumes the electronic configuration of neon. Now, can we consider the electronic configuration of the chloride? The parent atom has the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. And we check it. We have 2 plus 2, that's 4, plus 6, 10, plus 2, 12, plus 5, 17. So the parent atom has 17 electrons. But in chloride, the chlorine has attracted one electron from the sodium. Therefore, it has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. Okay, this for the chloride. Now in chloride we have 18 electrons, which implies that the chloride assumed the electronic configuration of which element? That's right, it assumed the electronic configuration of argon. Make sense? Recall from the law of electrostatics, unlike charges or opposite charges attract. Therefore, the attraction between the sodium ion and the chloride ion results in the formation of ionic bond. The positively charged ion include the metallic ion, the ammonium ion, and hydrogen ion. While the non-metallic ion, the hydroxide ion, are negatively charged ion. Moving on, we have another CYK question right here. Check your knowledge. What type of bond is found in magnesium oxide, MgO, and why? Before we consider this question, we need to understand how bonds are formed between atoms. In bond formation, there is always an interaction between the metal and the non-metal. The metals, they tend to exchange electron with non-metal. The metallic atom will lose electron, while the non-metallic atom will gain electron. So when the metallic atom loses its electron, it becomes positively charged. And when the non-metallic atom gains the electron, it becomes negatively charged. During the exchange of electron, metals become positively charged, while the non-metal becomes negatively charged. So the exchange of electron results into the bond formation. When we have bond formation as a result of the loss of electron by the metals and the gain of electron by non-metal, it do result into ionic bond. Ionic bond is also known as what? Electrovalent bond. Now back to our CYK right here. The magnesium oxide is written as MgO. So the metallic atom right here is the magnesium, which loses 2 electrons to form Mg2+. And the oxygen atom gains 2 electrons to give O2-. Now the interaction between Mg2+ and the O2- results in the formation of the ionic bond. So we can equally have it as Mg2+ plus O2-, which results into formation of MgO. Make sense? What type of bond is formed by magnesium oxide? The bond type is ionic bond, also known as electrovalent bond. Why? This is because there is an exchange of electron between the metal and the non-metal. The metal, which is the magnesium atom, loses 2 electrons to give Mg2+, while the non-metal, which is the oxygen atom, gains the 2 electrons from the magnesium and becomes O2-. Since the exchange of electron results into loss and gain of electron by the 2 bonded atoms, we can equally say that it is what? Ionic or electrovalent bond. Make sense? Recall that ions are only mobile when the electrolyte is in molten or aqueous state. How do we transform sodium chloride from its solid state to a molten sodium chloride? We subject the sodium chloride solid to high thermal energy, that is heat energy of about 801 degrees Celsius. Therefore, the sodium chloride solid tends to melt. So when it melts, it forms molten sodium chloride. The molten sodium chloride contains mobile electron. So the other approach to achieve a mobile electron in the electrolyte is to dissolve the sodium chloride solid in water. So the dissolution of the sodium chloride in water builds up the mobile electron, which moves randomly in the electrolyte. As we can see in the diagram right here, we have the positively charged ion as well as the negatively charged ion moving randomly in the solution of what? The electrolyte. Moving on, can we observe this chart closely? So we have this. It can be observed from this chart right here that the compartment contains two plates. We have a plate right here and the other plate right here. The plate on the left hand side is positively charged plate, while the plate on the is a negatively charged plate. So this positively charged rod or plate is referred to as the anode, while the negatively charged plate is referred to as the cathode. So we have the anode and the cathode right here. Then the solution of the ion, that is the positively charged ion as well as the negatively charged ion, is known as the electrolytes. So the positive electrode, which is the anode, as well as the negative electrode, which is the cathode, are introduced or dipped into the solution, which is what? The electrolyte. So the electrolyte consists of the positively charged ion as well as the negatively charged ion. So when an electric current is passed through an electrolyte from the battery right here, so let's introduce our battery gradually. So we have this. So the battery has been connected to have a complete setup. What is the effect of the battery connection? The free ions that we have right here will lose their random movement once a battery is connected. Then the positive ions becomes attracted by the cathode. Okay, the cathode is the negative electrode. We can observe that we have the migration of the positively charged ion towards the negative electrode, which is the cathode. So the ions that migrate to the cathode are called the cation, also known as cathode ion. Also, it can be observed that the negatively charged ion migrates to the positive electrode, which is called the anode. Okay, now the ions that migrate to the anode are called anions, the negatively charged ion, that is the anode ions. Therefore, the current through the electrolyte is carried by movement of ion to the electrode and not by flow of electrons in the electrolyte. What are the applications of ionic theory? Ionic theory is everywhere in chemistry. The knowledge of ionic theory is applied in acid-base reaction, salt formation, water purification, electrolysis, as well as battery function. Now, can you attempt the quick test right here? Which of these will conduct electricity when dissolved in water? Option A, sugar. B, sodium chloride. C, ethanol. D, urea. If this lesson made ionic theory crystal clear, hit the like button, share with your study group, and subscribe for high clarity chemistry lesson. See you in the next video, and thanks for watching.